Hello and welcome to Math with Mrs. Becker. Today we are looking at Algebra 2, Chapter 2, Section 6, where we will be transforming linear functions. Back in Chapter 1, Section 8, we transformed functions by transforming every single point. Well, there are actually rules that allow us to change a whole function rather than just one point at a time. And that's what we're going to look at. If I take a line, because we are studying linear functions, if I take a line and I want to do a horizontal shift, remember horizontal lines run left and right. So what I'm doing here is taking the line and either sliding it to the left or the right. The formula to do that looks like this. It is x minus h. H is the horizontal value that you want to move. If you fill in a positive value, you would be sliding to the right. If you fill in a negative value, you would be sliding to the left. So let's say I want to slide something to the right too. It would be f of x minus, if I want to go to the right 2, I would fill in a 2. So this is right 2. Notice if I put a positive value in here, the negative remains. If I want to go to the left 2, it's x minus, if I want to go to the left, your h value is negative, so it'd be negative 2. Well, if you minus a negative, this ends up being x plus 2. So this is actually going to the left 2. So that's where it gets a little bit tricky. If you're going to the right, you put a positive value in there so the negative stays where it is. If you're going to the left, you put a negative in with a negative, minus a negative changes it to a plus. That means you're going to the left. Anytime you're adding or subtracting, it is a shift or a slide or a translation. It just means you're sliding the graph over. Now, if you want to do a vertical shift, remember vertical lines slide up or down. What you do here is rewrite the original function the way it is. Add or subtract to the end. So let's say I want to move up 2. If you're moving up, your k, the value is greater than 0. So I would rewrite the function to go up 2. You would just add 2 to the end. Okay, so here's an example for up 2. If I want to go down 2, you rewrite the function the way it is. If k is less than 0, it will move down. So if I subtract 2, that 2 has a negative value, so we would be traveling down 2. Okay, now this just means rewrite the function exactly how it was. Here, it means wherever there was an x, you replace the x with whatever's in the parentheses. And we'll try a few of these. If you are reflecting something across the y-axis, remember your y-axis runs up and down. If this was like a mirror image and you want to flip things over that line, what you do is you change all of the x's to a negative. So wherever there's an x in the problem, you put it in parentheses with the negative side. Then from there you can simplify it, but by keeping just the x as negative, it's going to flip over the y-axis. Okay, if I want to flip over the x-axis, what you have to do is put a negative out front of the original function. So you will be distributing, you'll distribute that negative into every term of the original function. Okay, so negative out front flips it upside down. You're flipping over the x. Negative just with the x, you flip it side to side. You're flipping over the y. Okay, so let's go ahead and try some. If f of x is x minus 2, if I want to do a horizontal translation to the right 3 units, what happens? Remember, it's f of x minus. If I want to go to the right 3, I will fill a 3 in. So this is the rule. What this means is where I have an x, I have to change it to x minus 3. So here's an x. X minus 3 goes in its location, minus 2. Now I can go ahead and combine like terms, so I'd have x, negative 3 minus 2 more is negative 5, and you're done. Okay, if I want to go 2 units to the right, remember the formula is x minus whatever direction you want to go. This is a positive 2, so I put in, or I'm going to the right, so I put in a positive 2. It remains a minus. Wherever you have an x, you change it to x minus 2. This is 3 times x, so I will need my x minus 2 to be in parentheses this time because I have to multiply 3 by whatever's in the parentheses. So I distribute. 3 times x is 3x. 3 times negative 2 is negative 6. The plus 1 is on the outside. I'd have 3x, negative 6 plus 1 is negative 5. So this figure would be the same line as this, just slid to the right 2. And this function is the same line as this, just slid to the right 3. Okay, let's go ahead and look at this. Let g of x be the indicated transformation of f of x. Write the rule for g of x. Well, we have to go ahead and figure out what that line is. So first we have to write the line for f of x in slope-intercept form. Okay, so it's tying it back to what we've done already in this chapter. If you want to know the equation of a line and you have 3 points, you pick 2, any 2 points. I chose 0, 1, and 2, 2 because I did not want to deal with that negative sign. This would be x1, this would be y1, this would be x2, this would be y2. Your first step when you are trying to find the equation of a line, if you know 2 points, you have to find the slope. So the second y2 minus the first y1 over second x2 minus the first x0. 2 minus 1 is 1. 2 minus 0 is 2. So the slope is 1/2. But they didn't ask for the slope. They said slope-intercept form. That's an equation. So once you know the slope, you need 1 point. Well, I'm going to choose the 0, 1 because those are the easiest numbers to work with. Y minus the y from the ordered pair I chose. It's a 1. Equals m, 1/2. X minus the x from the ordered pair. If I go ahead and I distribute, I'd have y minus 1 equals 1/2 times x is 1/2 x. 1/2 times 0 is 0. So I don't even have to show that. If I add 1 to each side, y equals 1/2 x plus 1. Now that's the equation of the line. That's our f of x. If we want to go ahead and reflect this function across the x-axis. If you want to reflect it across the x-axis, what this looks like is negative f of x. So you have to go ahead and distribute a negative into the whole function. Remember, y and f of x are interchangeable. Okay, so y equals 1/2 x plus 1 is the same thing as f of x equals 1/2 x plus 1. So if I want to flip something upside down, meaning that I want to reflect it over the x-axis, I have to put a negative out front of the entire function. So the negative goes out front, it has to be distributed. So your new function, which they're calling g of x, is negative 1/2 x minus 1. Okay, so it's just going ahead, distributing a negative is how you flip it across the x-axis. Okay, let's do another one just to make sure we've got it, okay? So if you have a table with 3 points, you need, what we're doing now is we are transforming equations. So you need an equation. To get the equation, you pick 2 ordered pairs. So I'm going 0, 2, and 1, 3. M, the second y3 minus the first y2 over second x1 minus the first x0. 3 minus 2 is 1. 1 minus 0 is 1. 1 over 1 is 1. So my slope is 1. Now what I need to do is use the slope and 1 ordered pair. I picked 0, 2 because I get to work with the 0. Y minus the y value from the ordered pair you chose equals m. M is a 1. X minus the x value from the ordered pair you chose. Distribute. So y minus 2 equals 1 times x is x. 1 times 0 is 0. So I don't have to show that. Here I add 2, so y equals x plus 2. That is your original function. They are calling that f of x. Now, if I want to write the rule for g of x, it has a new name because we're changing it. If I want to write the rule for g of x and have it reflect across the y, the rule says if you reflect across the y, you change all of your x's to negative x. So I go into this function, wherever there's an x, I change it to a negative x. Now here, because I'm not distributing, I don't have any parentheses, anything like that, I would not need to keep the parentheses. I could simply say that the x now became a negative x plus 2. Okay, so far we have taken lines, slid them up, down, left, right, flipped them over the y, so it's side to side, flip it upside down, so it's over the x. Another thing that you can do are stretches and compressions. What happens when you're working with lines is when you do stretches and compressions, your lines can become steeper or your lines can become flatter. Let's look at some of those. Okay, here are the rules. If you are doing a horizontal stretch or compression, your change will be in parentheses. Okay, just like if it was a horizontal slide, you were adding or subtracting in parentheses. If you are doing a horizontal stretch or a compression, you are multiplying in parentheses. Okay, the rule is it's 1 over the scale factor times x. If your scale factor is a value greater than 1, it is called a stretch. If your scale factor is a value that is less than 1, it is called a compression. But because of this rule, it's 1 over the scale factor. In order to figure out if you have a stretch or a compression, you look at the formula and you have to do the reciprocal. Okay, 1 over a value is a reciprocal. So what you have to do is flip it. Once you flip it, if the value is bigger than 1, it's a stretch. If the value is less than 1, it's a compression. Okay, if it is a vertical stretch or compression, you are distributing a value into the original function. So whatever this value is, your scale factor, it has to go to every term in f of x. Now this value, you keep it how it is. If it's bigger than 1, you stretch. If it's less than 1, it is a compression. Okay. Just little helpful hints as you are graphing, which we will get into. Y-intercepts in a horizontal stretch or a compression, they won't change. Your y-intercepts won't change. If you are doing a vertical stretch or a compression, your x-intercepts won't change. Okay, so just something that's going to be coming up. Okay, let g of x be a horizontal compression of f of x equals negative x plus 4 by a factor of 1/2. Okay, so it's a compression because the factor is 1/2, that is less than 1. Horizontal, the rule is f of 1 over b times x. So here, this means take the reciprocal of the scale factor. The scale factor is 1 over 2, so if I flip it, it's 2x. Any x's in this problem are replaced with whatever is in parentheses. So it's negative 2x plus 4. The negative times 2x would give you negative 2x plus 4, and we're done. Okay, if I have f of x as 3x plus 2, and they want us to do g of x, just meaning that we're having another function, okay, we're changing it. So if I'm starting with 3x plus 2, and they want g of x to be a vertical compression by a factor of 1/4. It's a compression because 1/4 is less than 1. Vertical, that's where you have to distribute whatever the factor is into the original function. So 1/4 times 3x. Remember fractions, you take top times top, bottom times bottom. So this is 3/4 x plus top times top, bottom times bottom. You'd have 2 over 4. 2 over 4 can be reduced to 1/2. So again, horizontal, your change is in the parentheses, so you only change the x. Vertical, your change goes out front, so you distribute and change everything. Some linear functions involve more than one transformation. By applying individual transformations one at a time in the order in which they're given. So they might have you do a bunch of transformations. You just have to take a big breath, not worry about how many you're doing. Start at the beginning of the problem and do one transformation at a time. Let's go for it. Okay, so let g of x be a horizontal shift of 3x left 6 units. Okay, so this is what we're starting with. F of x equals 3x. Horizontal shift. Anything that's horizontal, your change is in the parentheses. Adding or subtracting is how you would show a shift, a slide, or a translation. They all mean the same thing. It's minus, if I'm going to the left 6, I put a negative 6 in there. Well, minus and negative changes this to plus 6. The formula has a minus. If you're going to the left, you're filling in a negative. Minus and negative is how I get a plus. What this means is in the problem, where there's an x, you have to change it to what's in parentheses. So your new function would be 3x plus 18. Okay, so I did that. Horizontal shift, left 6 units, followed by, that means I'm starting here now, followed by a horizontal stretch by a factor of 4. So what we're doing for horizontal stretch, remember the change is in parentheses. Whatever the factor is, it's a factor of 4, you have to do the reciprocal. So it's 1/4 x. Because it's horizontal, I only change the x in the function. So it's 3, x becomes 1/4 x, because you always take the reciprocal when it is a horizontal stretch or compression. Now to cancel the parentheses, I multiply. Top times top, bottom times bottom. This is 3/4 x plus 18. Okay, let's look at another one. Let g of x be a vertical compression of f of x equals x. Okay, so f of x equals x, that's the start. Vertical compression by a factor of 1/2. If it is a vertical compression, that's where it goes out front. So what this means is I have 1/2 out front. You distribute it to every term. This time it just happens to be one term. But for a vertical compression, you distribute your 1/2 to everything. Followed by a horizontal shift. Okay, so right now I have f of x equals 1/2 x. Horizontal shift, that's where I'm adding or subtracting in parentheses. It's x minus, if I want to go 8 units to the left is the negative direction. Well, minus and negative, it's really x plus 8. So what I have to do here is replace the x with the group x plus 8. Now I would go ahead and cancel the parentheses by distributing. 1/2 times x is 1/2 x, plus 1/2 times 8 is 4. So we started with x. We did a vertical compression by a factor of 1/2. That got us to 1/2 x. Then we did a horizontal shift to the left 8, which got us our final function, 1/2 x plus 4. Okay. The golf team is selling t-shirts as a fundraiser. The function R of n equals 7.5n represents the team's revenue in dollars. N is the number of t-shirts sold. So what this tells me is that n is the number of shirts. The team is getting $7.50 per shirt. Okay. The team paid $60 for the t-shirts. Write a new function for their profit. Profit is how much you get to keep. So revenue is how much they collect. So they must be selling the shirts for $7.50. So the money that they would have at the end is $7.50 times the number of shirts that they sold. Now they paid this, so this is called a cost. So to figure out your profit, you take your revenue, how much you collect, minus your costs, because you have to pay the bills. What you have left, that's what you can put in your pocket, that's your profit. So here, your profit is your revenue, 7.5n, the money you collect, minus your $60. The transformation of this is, I kept this the same, I minus to the end, so that is a vertical slide or shift or translation. Because it was minus 60, it went down 60. Whatever the revenue was, you had to minus 60, so that amount of money went downwards because you were paying the bill. One more. The dance team is selling beaded purses as a fundraiser. This is the function, 12.5N. It is the club's revenue, how much money they are making in dollars, where N is the number of purses sold. So here they are selling every purse for $12.50. The club paid $75 for the materials needed to make the purses. Write a new function for the profit. Okay, so we have profit, $12.50, N. You have to pay the bills, so you would minus 75. And again, this is a vertical slide or shift down because I'm minusing 75. It says, what if the club members decide to double the price of each purse? Well, if they decided to double the price, you would have to take 2 times 12.5N. Your revenue, how much money they collect, would double. 2 times 12.5 would be 25N. Okay, so the club members' decision, their club members decide to double the price of the purse. So if I go back to the revenue, instead of having $12.50 per purse, it's now $25 per purse. What transformation is this? We did not change the N. What we did is multiplied the whole thing by 2. So this is called a vertical stretch. The reason why it's a stretch is because 2 is bigger than 1. Your assignment is a worksheet. Now, typically in the past, a lot of people struggled to get started with the worksheet. So I'm going to go ahead and do a few questions with you just to make sure that you've got it, okay? Now, the beginning, they just want you to say that your function is f of x. They're not giving you an actual equation. So if I want a vertical translation down 3, you rewrite f of x, however it is. And in this case, it's just f of x. To go down 3, you would minus 3. If I want a horizontal stretch by a factor of 4, horizontal, so the change is going to be in parentheses. Stretches and compressions, you're multiplying. For horizontal, you have to do the reciprocal. The reciprocal of 4 is 1/4 x. If I want a vertical compression by a factor of 1/4, this is a compression because 1/4 is less than 1. If it's vertical, you multiply it out front of the function. That's one where you would go ahead and distribute. Horizontal translation, which is the same as a slide or a shift, 5 units left. The formula is f of x minus. If I want to go 5 units left, left is the negative direction, so I would fill in a negative 5. Minus a negative becomes a plus. Okay, next one, horizontal compression. So when you see horizontal, that change is going to be in parentheses. Stretches and compressions, you have to do the reciprocal of the factor. The factor is 2/3, so in the formula, it's going to be 3/2 times x. Last one, if I'm doing a reflection across the y, if you reflect something across the y, that's where you only change the x's. Okay, so the top ones, excuse me, like I said, this is where in the past people kind of got confused since you did not have an actual equation to change. They just wanted to make sure that you understood the rules. Now starting here, this is similar to what we did in the notes. So if I have 2x, that's my function. If I want to shift the graph vertically 2 units, well, a shift means you're adding or subtracting. Vertically means to the end. If you want to go 2 units, that's a positive value, so you would have 2x plus 2. If I want to do a horizontal stretch by a factor of 3, horizontal stretches and compressions, you make the change in parentheses. It's the reciprocal of whatever the factor is. So what I have to do here is change the x to 1/3x, but I don't change anything else. If it's horizontal, the change only goes to the x. That's why it's in parentheses. Okay, last one, and then, I know I said that earlier, and then I get excited and I keep working with you. We will end after this, and I'll let you go ahead and try some on your own. If I have x/4 and I do a vertical compression by a factor of 3/4, remember, x/4 is equivalent to 1/4 x. Okay, so you could think of it that way if that helps you. If you're doing a vertical compression, you take whatever the factor is and you distribute it to the entire original function. So here you're multiplying. Top times top is 3. Bottom times bottom is 16x. So I did more than half of side A with you. So what you'll do for your assignment is go ahead and finish side A and check out side B. I hope you guys had a great day today learning about transformations, and I will talk to you soon.